in all of our cells. When this process is mutated or there's an RNA splicing error, it actually causes devastating diseases. Fortunately, we're part of a lab at Cold Spring Harbor in New York that was able to develop a synthetic RNA therapeutic that is actually able to affect and treat spinal muscular atrophy, which is a number one genetic cause of children's death, and it's a devastating disease. So what we realized is that these kids that couldn't move a single muscle were now able to walk with this small RNA therapeutic. And as you can see here, this is a happy story. Now the kids are walking, as you can see in the picture. And my co-founder, while at the lab, actually had developed and used all his machine learning expertise from Technion to develop other drugs like this one for different diseases. So what we did was we licensed out the technology and we started Envisagenics. So today I told you a little bit about RNA splicing is actually able to solve and fix RNA splicing diseases. So you're probably wondering what RNA splicing is. RNA splicing is how your genetic information is actually translated into proteins. Proteins is what makes our bodies work properly. So, for instance, in this sentence, we have a code or a sentence. If your RNA sequence looks similar to this, it actually, in the white letters, could produce a sentence that says, draw a big house on the corner of the white street. And it has a bunch of pink gibberish letters in between. RNA splicing is the process that takes that gibberish out and actually makes a coherent sentence. However, as I said, if there's RNA splicing errors that happens in our bodies, it actually can cause devastating diseases. So in our analogy, we take word number 7 out of the sentence and produces no longer a sentence that makes sense. In our case, if your RNA sequence has an RNA splicing error, it does no longer make a protein. And in doing so, it causes genetic disorders just like SMA and many others. So we developed a software technology at Cold Spring Harbor Lab that allows us to use your genetic code and find these RNA splicing errors. And in doing so, we can then develop RNA therapeutics for them.